All right, so are you interested in Python for finance? Want to see what a leading online certification program in the field is all about? Well, you're in luck. Today we're diving into some free online bootcamp videos from the Python Quants, the folks behind the renowned certified programmer in finance, or CPF program.
Yeah, it's a fantastic opportunity to get a taste of their teaching style and see if their full CPF program is right for you. We've got excerpts from the first 3 sessions, and what's really cool is that the entire boot camp is very hands-on. They actually walk you through setting up your Python environment for finance from scratch.
And get this, they even show you how to do it all in a Docker container in the cloud, all for free. Talk about breaking down barriers to entry.
Exactly. It's a brilliant approach because everyone starts with the same setup, eliminating those frustrating my computer's different issues. This means you can follow along and get the exact same results no matter when you're watching.
Okay, let's unpack their teaching philosophy. They have a Python-first approach, which I love. They jump right into the coding, focusing on building the tools and skills you need step by step. It's refreshing to see such a practical approach.
Absolutely. And it's really smart that they use static data files throughout the boot camp. You can be confident that you'll get consistent results, which is especially important in finance where data sources and APIs can change constantly.
They start by covering the absolute core Python concepts. The essential building blocks like data types, lists, and dictionaries. These are things you'll use all the time in financial work.
And here's where it gets really interesting. They actually have you recreate a real-world financial analysis task. First using pure Python and then using NumPy. The difference in speed is mind-blowing.
You're telling me. They show you how NumPy can make your code run 100 times faster. I mean, that kind of speed boost is a game changer when you're crunching massive financial data sets.
NumPy is like your secret weapon for financial number crunching. What's fascinating is that they go beyond the basics and show you how to use NumPy for simulating stock prices, analyzing risk, and even valuing complex financial instruments like options using Monte Carlo simulation.
Wait, hold on. For those of us who aren't finance wizards, could you explain Monte Carlo simulation and why it matters in this context?
Of course. In simple terms, Monte Carlo simulation is a way to estimate the probability of different outcomes by running a ton of simulations with random variables. In finance, it's used for things like option pricing, where you're trying to figure out how much an option is worth based on the potential future movements of the underlying asset.
Okay, that makes sense.
Yeah,
So they're showing you how to use NumPy to build these powerful simulations. That's pretty impressive.
exactly. It's really impressive what you can do with just a few lines of code using NumPy. But they don't stop there. They also introduce pandas, which builds on NumPy and makes working with tabular data super efficient. Think of it like a spreadsheet on steroids.
You mean like being able to import real-world financial data like stock prices or gold prices with just one line of code?
Exactly. And they go even further, showing you how to build interactive charts right in your code, which is incredibly helpful for exploring and visualizing financial data.
They really seem to emphasize a practical hands-on approach, which I appreciate.
Yeah.
But let's get back to that example you mentioned earlier, where they compare pure Python to NumPy for a simple financial analysis task. What was it about that example that stood out to you?
Well, I thought it was a brilliant way to highlight the power of NumPy. They intentionally start by doing things the long way using pure Python and basic data structures like lists, just to illustrate the difference.
So you can see how the logic works step by step, which is great for learning, but then they show you the NumPy magic, right?
Right. They introduce NumPy and demonstrate how to accomplish the same task using vectorized operations. Not only does the code become significantly shorter and more elegant, but the performance difference is astounding.
They actually time both approaches right. And the NumPy version just blows the pure Python version out of the water.
Exactly. We're talking over 100 times faster. It's a powerful demonstration of why NumPy is so indispensable in finance. That kind of speed advantage is crucial when you're working with large data sets or running complex simulations.
It's not just about speed, though, is it? From what I understand, NumPy also makes your code more concise and readable.
Absolutely. And that's crucial when you're working on complex financial projects. They do acknowledge that there are situations where a pure Python approach might be more memory efficient, but their focus is clearly on speed and efficiency. They want you to think like a speed junkie, always looking for ways to optimize your code.
That's a great analogy. So they lay the foundation with Python, then introduce NumPy for serious number crunching. What comes next in their Python for Finance Bootcamp?
Well, after they've really hammered home the power of NumPy, they dive into the world of random numbers. It might sound a bit abstract, but it's a fundamental concept in financial modeling, especially when you're dealing with things like risk and uncertainty.
Right, because in the real world, financial markets are anything but predictable.
Exactly. So they introduced NumPy's random number generation capabilities, showing you how to generate large arrays of random numbers incredibly quickly using NumPy's built-in functions. Again, the emphasis is on speed and efficiency.
And I bet they compare NumPy's random number generation to Python's built-in random module just to showcase the difference, right?
You know it.
Yeah.
They highlight those significant performance advantages, and they even take a moment to explain the concept of pseudo-random numbers, which is how computers actually generate seemingly random sequences of numbers.
That's always fascinating to me. It's like a peek behind the curtain of how computers simulate randomness.
It is,
Yeah.
and they touch on the importance of using a good random number generator, especially for financial applications, where the quality of your random numbers can directly impact the accuracy of your results.
Okay, so they've equipped you with the tools to generate random numbers. What do they actually do with them? How does this tie back into the world of finance?
Well, that's when they start diving into some really interesting financial applications. They begin by simulating a stock price process. Think of it as a model of how a stock price might change over time.
So instead of looking at historical data, they're simulating potential future movements.
Precisely. They start with a simple model based on geometric Brownian motion, which is a common way to model asset prices.
And I bet they show you how to translate that complex mathematical concept into Python code using NumPy, right?
Of course. They break it down step by step, making it accessible to anyone with basic coding skills. And then they visualize those simulated stock price paths using Matplotlib so you can see how the stock price might evolve over time.
That's a great way to make it more concrete and understandable. So they're simulating stock prices. What else do they cover in this section?
Well, they introduce a benchmark example from a famous academic paper on option pricing and use this example to demonstrate how to value a European put option using, you guessed it, Monte Carlo simulation.
So they're connecting these theoretical concepts to real-world financial problems, which is awesome.
Exactly. And they walk you through the entire process from setting up the simulation to calculating the option price. They provide specific values for all the parameters in the model, including the initial stock price, the strike price of the option, the risk-free interest rate, and the volatility of the stock.
That's great for anyone following along at home. It means you can reproduce their results and see how it all works.
Exactly. They even show you how to calculate the present value of the option by discounting the future payoff back to today, which is an essential concept in finance.
Okay, so they've covered European options. Do they delve into any other types of options?
They do. They take things a step further and show you how to value an American put option, which is more complex because it can be exercised at any time before its expiration date.
That does sound trickier. How do they approach that?
To handle the early exercise feature of American options, they introduce a powerful technique called least squares Monte Carlo, or LSM. It's a groundbreaking algorithm that combines Monte Carlo simulation with regression analysis to estimate the optimal exercise strategy for the option holder.
Wow, that sounds pretty sophisticated. Do they really explain all of that in this free bootcamp?
They do. They break down the entire algorithm step by step, explaining the intuition behind each part of the process. They even go through a quick refresher on linear, quadratic, and cubic regression just to make sure everyone's on the same page.
That's a really helpful approach.
Yeah.
I can see how this would be a fantastic way to learn about these complex concepts without feeling overwhelmed.
Exactly. And then they walk you through the Python code for implementing the LSM algorithm. Comparing their results to the benchmark values from that academic paper we mentioned earlier, they even show you how changing the degree of the polynomial used in the regression can affect the accuracy of the option price estimate.
It's incredible how much they pack into this free bootcamp. It's like a masterclass in using Python and NumPy for financial modeling.
It really is. And after this deep dive into option pricing, they switch gears and introduce the concept of structured arrays in NumPy.
Structured arrays, what are those?
Think of them as a way to work with arrays containing data of different types. For example, instead of just having an array of numbers, you could have an array where each element contains information about a person, including their name, age, and height.
Okay, I can see how that would be useful.
Yeah.
But how does this apply to finance?
Well, they demonstrate how to use structured arrays to represent financial data, which is incredibly helpful when you're dealing with data sets containing different types of information, such as stock prices, trading volumes, and dates.
So it's about organizing and managing complex financial data more effectively.
Exactly. And to illustrate the power of structured arrays, they revisit that example of importing data from a CSV file. Remember how we previously used pure Python to import the data and then used NumPy to work with it?
Right. They showed us both ways to highlight the efficiency of NumPy.
Exactly. Well, they show you how to use NumPy's gen from next function to directly import the data into a structured array, eliminating the need for all that manual parsing and conversion.
That sounds like a huge time saver, especially when you're working with large data sets.
Absolutely. They explain each parameter of the gen from text function, carefully showing you how to specify the data types for each column, handle missing values, and even define custom functions to convert the data.
So they're really giving you the power to control how the data is imported and structured.
Exactly. And once the data is in a structured array, they demonstrate how to access and manipulate the data easily using NumPy's powerful array operations. They even recreate some of the visualizations we saw earlier, like the plot of the euro-US dollar exchange rate and the histogram of Apple's stock price returns using the data from the structured array.
It's amazing how smoothly they transition from pure Python and lists to leveraging the efficiency and flexibility of NumPy's structured arrays.
And they make it clear that this approach can be applied to all sorts of financial data, including intraday data, tick data, and even data from different asset classes.
It's all about equipping you with the tools to handle real-world financial data in a clean, efficient, and, dare I say, Pythonic way.
You got it. And you know what? This sets the stage perfectly for their introduction to pandas, which takes data manipulation and analysis to a whole new level.
Okay, I'm intrigued. Let's take a deep dive into pandas in the next part of our deep dive into the Python Quants free bootcamp.
Welcome back. Remember all that data wrangling and number crunching we're doing with NumPy? Well, get ready to take your data skills to the next level, because now we're diving into pandas. It's built on top of NumPy, but adds a whole suite of tools specifically for working with tabular data, the kind you'd see in a spreadsheet.
I've heard so much about pandas, especially for finance. Is it really as powerful as everyone says?
Yeah.
What makes it so special?
Oh, absolutely. The core of pandas is this thing called a data frame, which is basically like a supercharged spreadsheet on steroids. You can store, manipulate, and analyze data in a way that feels intuitive, yet incredibly powerful.
Okay, that sounds intriguing. How do they introduce pandas in the bootcamp? Do they assume you already know it?
Not at all. They start nice and easy, showing you how to create a data frame from a NumPy array, which makes sense since pandas builds on NumPy's foundation. It's a smooth way to get you comfortable with the pandas way of thinking.
So you can see the connections between the tools, which is always helpful.
Mm-hmm.
Do they also show you how to create a data frame from scratch, like if you're not starting with a NumPy array?
You bet. They walk you through defining the column headers and data types for each column, just like you do in a spreadsheet. And here's a cool trick. They even show you how to create a data frame with a date-time index, which is super handy when you're working with time series data, like stock prices over time. That's bread and butter stuff in finance.
Ooh, that's smart. Okay, so you've got your data in a data frame. What kind of data manipulation magic can you do with pandas?
Get ready for this. They show you how to select specific rows and columns from a data frame, filter the data based on certain criteria, and even perform calculations on entire columns or rows at once. It's like having spreadsheet superpowers, but with the speed and efficiency of NumPy backing it all up.
Wow, that sounds way more efficient than wrestling with spreadsheets. Do they cover any financial specific calculations or analyses?
Absolutely. They demonstrate how to calculate rolling statistics like moving averages, which are super useful for technical analysis and spotting trends. They also cover how to handle missing data, which is a common problem in real-world data sets, using Pandas' built-in functions.
Missing data can be a real headache. It's great that Pandas has tools to deal with that. So they're covering data cleaning calculations. What else?
Oh, it gets even better. They show you how to reshape and pivot the data, which is incredibly helpful when you need to analyze the data from different angles.
I love that pivoting the data to see different perspectives. It's like rearranging the pieces of a puzzle to get a clearer picture.
Exactly. And one of the things that makes Pandas so powerful for finance is its ability to handle time series data with ease. They show you how to resample the data to different time frequencies, like converting daily data to weekly or monthly data.
That's super useful, especially when you're looking at trends over different time horizons.
Exactly. They also demonstrate how to shift and lag the data, which can be really helpful for creating lagged features for machine learning models or analyzing historical trends.
Okay, so Pandas is clearly a data wrangling beast. But can it also help you visualize financial data?
You bet. Pandas has built-in data visualization capabilities that build on Matplotlib, but offer a more streamlined approach for creating common financial charts and graphs. They show you how to create line charts, scatter plots, histograms, even box plots directly from your data frames.
So you can easily go from data analysis to visualization all within pandas.
Yeah.
That's pretty seamless.
It is. And they don't just leave you hanging with basic charts. They also cover how to customize the appearance of your plots, adding titles, labels, and legends to make them more informative and visually appealing. It's all about telling a compelling story with your data.
That's a crucial point. Data visualization is about communicating insights, effectively, not just making pretty pictures.
Absolutely. Okay, remember that real-world financial data we imported earlier using NumPy's structured arrays? Well, they circle back to that and show you how Pandas makes the import process even smoother and more efficient.
I'm all ears. How does Pandas streamline that?
They introduced this awesome function called readCSV, which is like the Swiss Army knife of importing data from CSV files. It handles data type conversions and missing value handling automatically, so you can import an entire data set with literally one line of code. It's incredible.
Well, one line of code.
Okay.
That's what I call efficient. So you've got your data in a pandas data frame. What kind of analysis do they show you how to do?
They demonstrate how to perform all sorts of calculations and analysis using Pandas' built-in functions. For example, they calculate the average euro-US dollar exchange rate, the standard deviation of Apple's stock price, and even the logarithmic returns of the gold price, all with just a few lines of code.
So pandas takes the heavy lifting out of financial data analysis. It's like having a team of data analysts at your fingertips.
Exactly. They also recreate some of the visualizations we saw earlier using the Pandas data frame. It's a seamless transition from NumPy to Pandas, showcasing how Pandas builds upon the foundation and offers even greater power and flexibility.
Okay, so we've gone from mastering the basics of Python to crunching numbers with NumPy, and now we're wrangling and visualizing data like pros with pandas. This bootcamp is really packing a punch. What comes next in our journey through the world of Python for finance?
Welcome back. It's amazing how much ground we've covered, from the fundamentals of Python to the intricacies of Pandas. But remember, this is just a taste of what the Python Quants cover in their full CPF program.
It's been quite a journey. We've learned how to manipulate data crunch numbers and visualize trends. It feels like we've built a solid foundation for doing some serious work in finance. But I have to ask, what about algorithmic trading? Isn't that one of the most sought-after applications of Python for finance?
You read my mind. That's precisely where they take us next in the bootcamp. They show you how to build a simple algorithmic trading strategy using all the skills we've developed so far.
Okay, color me intrigued. What kind of trading strategy do they build?
They start with a classic strategy called a moving average crossover strategy. It's a simple but surprisingly effective strategy that generates buy and sell signals based on the relationship between a short-term moving average and a long-term moving average of an asset's price.
Wait, hold on. For those of us who aren't seasoned traders, could you break down what a moving average is and why this crossover matters?
Of course. A moving average is basically a way to smooth out price fluctuations over time. Imagine plotting a stock's price over a period of time. The line might be pretty jagged with lots of ups and downs. A moving average takes a set number of data points, say the last 20 days, calculates the average price over that period, and plots that point on a chart as you move through time. You calculate a new average for each new data point, creating a smoother line that represents the average price trend.
Okay, that makes sense. So you have a short-term moving average maybe based on 20 days, and a long-term moving average maybe based on 50 days.
Exactly. Now, the crossover strategy says that when the short-term moving average crosses above the long-term moving average, it's a buy signal. It suggests that the short-term momentum is picking up and the price is trending upwards. Conversely, when the short-term moving average crosses below the long-term moving average, it's a sell signal, indicating a potential downward trend.
That's a pretty straightforward concept, but I can see how it could be powerful when applied consistently. So how do they actually build this strategy in the bootcamp?
Well, they use pandas, of course. They show you how to calculate these moving averages using Pandas' rolling function, which we explored earlier. It's amazing how they weave these building blocks together to create something as sophisticated as a trading strategy.
It really highlights the power of having a solid grasp of those fundamental tools. So they calculate the moving averages, then what?
They clearly define the trading logic. If the short-term moving average crosses above the long-term moving average, generate a buy signal. If it crosses below, generate a sell signal. Then they show you how to implement this logic in Python, generating a series of buy and sell signals based on the streaming data from our simulated tick data server.
It's like watching a trading algorithm come to life. Do they actually show you the signals in action?
They do. They visualize the trading signals right on top of the price chart so you can see exactly how the strategy would perform in real time. It's a really effective way to connect the theoretical concepts to the visual representation of the market.
That's awesome. But they also emphasize that this is just a starting point, right?
Right. They make it clear that you can build on this foundation, incorporating more sophisticated indicators, risk management rules, and even machine learning models to create more robust and potentially profitable trading strategies.
So they're not just giving you a fish. They're teaching you how to fish, or in this case, how to build your own fishing rod.
Exactly. They really empower you to take what you've learned and run with it, exploring your own ideas and developing your own unique approach to algorithmic trading.
But they also offer words of caution, right? Algorithmic trading can be pretty risky, especially if you don't know what you're doing.
Absolutely. They caution against the dangers of overfitting, which is basically when your strategy performs well on historical data but fails to generalize to new data. They also emphasize the importance of backtesting your strategies thoroughly before deploying them in live trading.
Backtesting, for those who might not know, is essentially simulating how your trading strategy would have performed on historical data.
Exactly. It's a crucial step to see if your strategy holds up under different market conditions and to make sure you're not just fooling yourself with a strategy that's overfit to a particular period.
It's like running a dress rehearsal before opening night on Broadway.
Exactly. And they really drive home the message that algorithmic trading is not a get-rich-quick scheme. It requires discipline, patience, and a deep understanding of both the markets and the tools you're using.
So no overnight millionaires from this boot camp. Darn.
Huh. Well, maybe not overnight, but they certainly provide you with the foundational knowledge and skills to pursue a career in this exciting field.
And as they wrap up the boot camp, they take a moment to recap everything you've learned, right?
They do, and they really highlight the incredible potential of Python for finance. They emphasize that Python has become the go-to language in the industry, a powerful and versatile tool that can be used for a vast range of applications, from data analysis and visualization to portfolio optimization and algorithmic trading.
It's amazing how Python has become the lingua franca of finance, isn't it? It wasn't always this way.
It wasn't. But Python's flexibility, its vast ecosystem of libraries, and its relatively easy learning curve have made it the language of choice for many financial professionals.
So what's their final message to aspiring Python for finance gurus?
They encourage you to continue learning and exploring, to dive deeper into the topics that sparked your interest, and to never stop pushing the boundaries of what's possible. They really inspire you to embrace the world of quantitative finance and to use your newfound knowledge and skills to make a real impact.
And that's a wrap on the Python Quants free bootcamp. What an incredible journey.
It really was. And I have to say, I'm even more impressed with their full CPF program now. They've clearly put a lot of thought and care into their teaching approach, and they're incredibly generous to share so much valuable information for free.
Absolutely. If you're all interested in Python for finance, I highly recommend checking out their free bootcamp videos. It's a fantastic way to get a taste of what they offer and see if their full CPF program is the right path for you.
It's an investment in your time that could pay off in a big way. Until next time, happy coding.